Well, you guys, I'm off to Royal City for a track meet. So today, here's our lesson. We are talking about solving radical inequalities, all right? And we got to be careful because one of the things we know is we can't have negative square roots, okay? So let's go back to what we had on our reading, okay? So you looked at the shaded region on this particular graph. One of the things you saw also is the fact that you think that the square root keeps going, but it doesn't. So you don't shade this back area at all because you want all of your x values to be greater than or equal to 0. So your y values can be negative, but your x values cannot. So that's why you get this particular graph here. And the same thing in the other example, when you take a look at this, there's two parts. That's why we talk about the range of values. See, if you're looking at the range of values, you just solve it like normal. Square both sides. You get 2x plus 4, subtract the 4, you get the 12, divide by 2, and you get 6. So you say, okay, x has to be less than or equal to 6. So if x is bigger than 6, it's not going to work, okay? But x will be less than 6. But you have to also be careful because there's another piece. And the other piece is this. This cannot be 0. I'm sorry, this cannot be negative. So I take what's inside the square root. I'm going to make sure I set it to be greater than or equal to 0 because it can't be negative. So the range comes from first solving it, and the second part comes from making sure it is not negative. So I set it to be greater than or equal to 0. So then I solve minus 4 divided by 2. So even though its x is greater than or equal to negative 2, even though that's negative, you plug it back in. If you plug negative 2 in, if you plug negative 2 into this, you will get negative 4 plus 4 is 0, and you'll be okay. But if x is smaller than negative 2, then you're in trouble. So you get the range. It's got to be less than or equal to 6, but it's also got to be greater than or equal to negative 2, okay? So what makes these two different? One is the fact that this one's graphing x and y, and this one's just solving for x. So let's look at our notes, okay? So our notes, example 1. Nearly the same problem. In fact, it is the same problem. So let's go through it again. So let's solve. This first step, let's square both sides, and then I have a 2x plus 4 is less than or equal to 16. The square cancels the square root, and 4 squared is 16. And then I'm going to go minus 4, 2x is less than or equal to 12, divide by 2, x is less than or equal to 6. So that's the upper limit. X has to be less than or equal to 6. Can't be 7, can't be 8, but it has to be 6 or smaller. But there's a lower range. We're looking for a range. We highlight the word range. Okay, highlight range because we want the range of values. So the range is this. We know that square roots can't be negative. So we take what's inside. That's the 2x plus 4. What's inside? We say, wait a minute. You cannot be negative. This piece cannot be negative. So make sure it's greater than or equal to 0. That's how we get the second part. Take what's inside. Can't be negative. So we set it to be greater than or equal to 0. Okay, let's solve. Minus 4. 2x is greater than or equal to negative 4. Divide by 2, x is greater than or equal to negative 2. So my range of values are that x has to be less than or equal to 6, or x is going to be greater than or equal to negative 2. Okay. Interval notation, it would be something like this, negative 2 comma 6. Or in set notation, you can just write it as negative 2 less than or equal to x less than or equal to 6. Or if you like these two, that works for me also. Okay, no problem. So let's look at example 2. Same type of problem. I'm going to set it up, and I'm going to go ahead and go minus 2. I'll have a square root of x minus 3 is less than or equal to 3. And to get rid of the square root, we square both sides, and then we wind up with our x minus 3 is less than or equal to 9. This isn't hard, is it? Plus 3, and we'll get x is going to be if I add 3 less than or equal to 12. That's the upper range. Okay. Now the lower, let's just look right here. Okay. We don't need to worry about the first part. We only need to look right here. This piece cannot be negative. So we're going to take what's inside. That's our x minus 3 and make sure that it is greater than or equal to 0. Okay. Just what's inside the square root. What's inside the square root cannot be negative. So plus 3, we're going to say x has to be greater than or equal to 3. If x, for example, there's my two answers. If x, for example, were say 1, we'd be in trouble. 1 minus 3. If x were 2, we'd be in trouble. So x has to be 3 or greater in order for us. And there's my range. Interval notation, I can go 3, 12, and there it is. Okay, example 3. Now it's a cube root. So the thing about a cube root is it really isn't a range of values. You can have negative values. So in this one, there is no range. We're just going to go ahead and solve it. To clear a cube root, I'm going to cube both sides, I will have x plus 2 is greater than or equal to 1 cubed is 1 times 1 times 1, which is 1. Minus 2, x has to be greater than or equal to negative 1. Okay, that's it. And you don't need to worry about a negative value because cube roots can be negative. So everything, our value is everything greater than or equal to negative 1. We'll go ahead and make sure this expression is greater than 1. Okay, so far so good. I'm going to turn the page. Okay, now, example 4 is different because you have an x and a y. So we're going to graph it. You have the y value, you know you're going to be on the xy plane. Okay, you have a y value, so it's going to be an xy plane. So let's go back to what we did yesterday. So yesterday, we know that if it's a square root graph, every square root graph looks something like this, right? There's our square root graph. 1, 4, and 9 are the key numbers we like, okay? Because the square root of 1 is 1, the square root of 4 is 2, square root of 9 is 3. So let's look for our end point. So we know the end point here is going to be at opposite, remember? Opposite, remember? Opposite inside. Opposite inside, so we're going to go to negative 1. Negative 3 is where my end point is. Negative 1, negative 3. There it is, okay? And then when I graph this, we'll go over 1, up 1, because the square root of 1 is 1. Remember this from yesterday? We'll go over 1, 2, 3, 4. We went over 4 for a reason, because the square root of 4 is 2. We'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, kind of off the page, but 3, there it is. Okay, so we want to use good numbers. 1, because there is a square root of 1. 4, there is a square root of 4. And 9, because there's a square root of 9, that's 3. Okay, let's go ahead and draw that in, okay? Okay, you want y to be less than. So again, we go below. Okay, so we're going to shade below, but we've got to be careful that we don't go past this value here. Okay, so before you start shading, right here at the end point, you cannot go on the other side because those will give me negative values. We cannot have negative square roots. So when I shade this, I'm shading everything below the square root graph, and we're going to make sure that we don't shade over into this negative region, which would be past the end point. Okay, and that's my solution. Okay, now you can also possibly do this on your calculator. Okay, so how do you graph these on your calculator? So I want to show you. Okay, so I have my calculator. I'm going to do my y equals. But before I do my y equals, I'm going to check my window. I always like to check my window, and that looks good. Negative 10 to 10 on my window. Scales by 1, negative 10 to 10. Okay, so y equals, and I can go square root of x plus 1 parentheses subtract 3. Now, we can go and put right here, we want to go less than or equal to. So I push enter, enter, enter. So we've done this before. We've done shading before, okay? So then if you take a look at this little triangle here is on the bottom half triangle, which means less than, okay? So if I graph this, check it out. There it is. There's the same graph I have on my paper, but it's on the calculator. Nice. We can do this on my calculator, huh? Okay, let's go to example 5. So we haven't seen this graph for a little bit, but we did this last chapter. What we know about these graphs is they look like this. Okay, we haven't done these for a long time, but they look like this, okay? And we know that they have asymptotes vertical and asymptotes horizontal, okay? So we're going to take this graph right now first. We're going to move it. So let's move this center point. We're going to move the center point to opposite to 2, negative 2, okay? So I'll take my center point and I'll move it to 2, negative 2. So okay, I'll go over 2, negative 2, and I'll put in my asymptotes, okay? So the first thing I'm going to do is put my asymptotes and my asymptotes, okay? Okay. And then I'm going to go ahead and put the graph in, and it is at 1, 1, 1/2, 2, and it looks something like this, okay? And the other half's right here, okay? And again, if I'm not sure, hey, we can always graph it, right? If you have a difficult time, say, well, Mr. Davies, easy for you, but I don't know how to do it, so let's take a look at it. If you're going to graph it, you got to remember the parentheses, 1 divided by parentheses x subtract 2 parentheses subtract 2 graph. Okay, so that looks like you've got an asymptote there on my calculator. Looks like a horizontal asymptote there. This weird squiggly thing is my asymptote. Now it doesn't look very good, but now where do we shade? So the way we can shade is two ways. One, we can test points to see which points are going to give me a value less than 0, okay? Or the way we can do it easily is to just go to my same thing less than or equal to. There it is. Okay, and we graph. And it makes sense if we want less than. So we want less than the curve. So it's going to kind of border with the asymptote. So if I look at my calculator, I'm going to be shading all of this down here. And I'm going to be shading all of this down here. And that is it. So homework is going to be 2 different pages simply because you're going to have 2 different types of graphs. You're going to be graphing just with x, not with y. Okay, so you'll be solving, getting your range values, solving your range values. And then the second part you'll be graphing with a y, and you're going to be shading. Okay, so there is your assignment. I expect you to do it, not on your phones. I expect you to get this done, all right?